The next day.
What's going on in there?
Huh?
Thank you. Let's say you finalize a released version and you're documenting your hard work. You're writing up some documents, adding some comments to the code, and fixing some code style mistakes. Obviously, you don't want to make any actual code changes in the process. How do you do that? I mean, how do you make sure you don't actually change the behavior of a program? You might say you can just use a linter, formatter, refactoring tool, or whatever is in your IDE. But can you trust them? Are you going to blame the formatter when it actually messes up your code? Might be old-fashioned and review the diff line by line like a real man. But then again, do you trust yourself? They say that science is all about eliminating our unreliable sixth senses. So how about we do just that? There's so many programming languages out there, I can't possibly go through them all. So I'll just pick the languages I think are relevant, categorize them into two groups, and go from there. So, compiled languages. Let's get back to the basics. You write your source code, give it to the compiler, and out comes your object code. Different platforms wrap the object code in different formats. Although the formats are all different, the contents they carry are basically the same. This. Modern operating systems store programs in data segments. You got stack, heap, BSS, data, and text. The stack and heap segments are dynamically allocated by the operating system, so we're only interested in text, data, and BSS segments. The text segment,
Sacred Jedi text!
is also called code segment. No one knows why it's named text, but you can think of it as a text for the Jedi, the computer, to read and execute. The data segment contains mutable global data. The data segment is rarely used in modern times. It was a quite handy segment back when memory was not plentiful. The read-only data segment contains immutable data, such as the string rituals in the code, and the const arrays containing the initial data for cryptic functions, CRC table, and random number generator, and so on. The BSS segment contains a sizable uninitialized static variables. So all the variables that are implicitly initialized to zeros, they are BS. There's a pretty good reason why modern operating systems segment programs that are like this, but that's a topic for another video. Now you know the segments are in there, how do you get them out? Enter object dump command. With this tool, you can disassemble the machine code in the text segment and hexdump the rest of the segments in an executable or library. Use the big D option to disassemble all the machine code and the S option to hexdump all the data segments in the file. You don't necessarily have to make sense of the data. All you need to know is that as long as the version of the toolchain, the code, and the recipe stay the same, the hexdump and the disassembled code should stay the same. Well, in theory anyway. This is not a perfect solution. If there's some sort of macro in the source code that changes every time the program is built, the binary will be slightly different. Even if that's the case, it won't be that difficult to tell the actual code change from the macros. Now that you know how to use object dump, you can disassemble the machine code and hex dump the program data before making cosmetic change to your code, make the change, and run the object dump on the new version. Then use diff to see if there's any change in the object code. The modern scripting languages are secretly compiled to something called intermediate representation, which you may know as bytecode or IL, intermediate language. They all basically mean the same thing. Not only is it for performance, but also to facilitate the implementation of the languages on various platforms. Similar to using object dump, you can use bytecode disassembler tools provided by each language stack to compare the bytecode. However, some languages were developed before bytecode became a thing, or their tooling is not built for this purpose. Another option would be using a code minifier to see if the same minified code is produced. I don't like this idea, but it's better than nothing. For Python scripts and modules, you can run this module on a source file or the entire directory to get the bytecode. For .NET C# and Visual Basic, the equivalent is ILDASM. For Java, you can use Java P command on class file to disassemble the bytecode. And lastly, there's JavaScript. You can use Node.js's undocumented feature to print bytecode produced by V8 engine, but you're probably better off using a code minifier. But actually, unit tests could have prevented